All right, here's a few news articles. The Supreme Court, this is one of the main reasons why Mitch McConnell did all sorts of extreme and unethical things to pack the Supreme Court with conservative justices so he can promote guns, which is a very important Republican value. So there are certain states where it is quite difficult to carry a gun in America, like California and New York. Only 1,000 people in New York City have the right to carry a concealed gun. They make it very difficult, and the Supreme Court has dodged the issue, and now they are planning to take it up. So they may ban states placing any limit on people carrying concealed guns, which would further increase the number of people running around with guns in America, which would certainly please the Republicans. And this is kind of amazing. A private school in Miami, the Sentner Academy, has gone beyond the usual misinformation about COVID and gone to a truly Trumpian level. They have now declared that any staff members that have been vaccinated must stay out of class and cannot be trusted, and no one further should get vaccinated because they believe that people who have taken the COVID vaccine emit harmful virus particles and are making the people around them sick. So this is, I think, the most extreme sort of Fox News right-wing stuff. And that's their position, which is an interesting one. We will see what happens here. There's only 300 students in that one, but this, I think, is a surprising extreme position, even in a land of amazing amounts of anti-science and anti-vax. They've really taken the cake there, suggesting that the vaccine is not only bad for you, but it makes you a danger to others to take the vaccine. This, of course, is complete nonsense. There's not a shred of truth in it, in case anybody has any question about that. And in the same spirit, the CEO of BaseCamp, which is a small tech company, I think it might even be in San Francisco, has tried to do the same thing another company tried a couple months ago. He says, we will have no more discussion of politics at work. We will have no more discussion of values, no more social discussions. We will not have any more benefits for things like child leave or anything like that. We will have no more like reconsidering past decisions or anything like that. So really, this is trying to roll the clock back, which is what essentially all these right-wing things are doing. If 30 years ago, 40 years ago, there was the Milton Friedman model that the business of a business is business, and that a corporation, if you make something like soda pop, your only goal is to sell more soda pop and make more money, and you should not think about anything else. And if any idea of whether this is really a good thing for the world or moral values or ethics is all nonsense. The only thing you do is maximize profit at your one activity, and thinking about anything else is forbidden. And he's trying to go back to that. Now, I think most Americans have gone beyond this, but this is this is part of the huge cultural divide that permeates everything. This is what's called being woke. It's considering like whether you're improving the world and whether your workers really should be taken care of and whether you're being fair to the underrepresented workers and stuff like that. And all that is rejected by the right as like a modern thinking that confuses us and makes us feel bad, and you should just shut up and go back to where all you do is think about making money and shut up with all that moral stuff. So we'll see if he can make it work. The other company tried to make it work, didn't get anywhere. If you try to push a value like that is wildly out of the norm for your community, then what you pretty much do is drive away the workers, and they rebel. So we'll see what happens. In Arizona, the Cyber Ninjas, a security company with no experience in voting and run by people who are mad Trump supporters and are convinced that the election was rigged, are now having a secret recount of Maricopa's ballots. They will not reveal their procedures. They will not allow journalists in, except for one or two that managed to sneak in. They don't have any idea what they're doing. They don't even know the rules. They don't even know the laws. They won't even say who's funding them. It is almost certainly going to be fraudulently exploited to make some kind of bogus claim that the election was improper, even though it's had many people go over it already, and that will probably just throw more gasoline on the fire raging in our country as I think it's 80% of all Republicans believe that the election was rigged and that Biden is not a legitimate president. And so we have, we have a serious divide with people that have completely incompatible views about how to run the country. And they're just getting more and more angry. And it shows up a lot of ways. And this will probably throw more fuel on the fire. I'm sure that the Fox News gang will say that these guys are right and everyone is lying about it. It would be interesting if the owner of CyberNinja is violating the CISSP code of ethics. Oh, yes, as a matter of fact, I think that is true. If he claimed to be competent to oversee an election when he isn't, that would certainly violate the CISSP code of ethics. Yeah, I don't know if they would care, but if they have a CISSP, you could submit an ethics complaint against them. Anybody could. Like I said, in my CISSP class, it happened to me. Even somebody like you or me that is not a customer and really doesn't know much of anything could submit an ethics complaint. Anybody can. I'm not planning to do it, but you can if you like. Anyway, so Kashmir Hill is a journalist that does a lot of exciting things like living for a month on Bitcoin and so on. Yeah, I don't plan to do it. Yeah, I don't plan to do it either. But anyway, so she eventually reported on a woman who was just sort of crazy, who had like slandered a lot of people. And it became clear that once she would just go on sites and post terrible things about people, like they are pedophiles or rapists or something. And then pretty soon it would be all over Google, so they couldn't get a job. They got fired, got kicked out of their church because anybody that Googled them would see all this terrible stuff. And what Kashmir Hill found out is it's really very hard to clean that off. And now they've been going much more deeply into it. So this guy made a nasty post about himself on something called Bad Girl Reports. And what they found is that this is all just a racket. There's all these sites that are about like how to report cheaters and people that have venereal disease and other people. And then if you go to these sites, there are ads saying remove the contents that are run by the same company. So this is all basically just revenge porn extortion. These sites are there to supposedly provide sort of Yelp for human interaction, but then they will vastly multiply any bad thing that appears, and then they will charge money to remove it. This is what Yelp did, by the way. Before Google bought them, Yelp was the same thing. It was an extortion racket. They would get bad posts about a restaurant, and they would then contact the restaurant and say, if you pay us for advertising, we'll remove that bad one. Otherwise, we'll push it to the top. They got sued for that, and hopefully they quit. Anyway, all right, I guess that's enough. We're down to the official time, and there's lots of good stuff to do here. So this is 127, and more guest speakers have appeared, and I think they're very good. So it has changed the schedule of this class. I'm going to talk about Windows tonight, and we'll have 2 guest speakers and only 1 more class after that. So that means we miss a little bit of the lecture, and I think I made a couple of homeworks or something turn into extra credit. So if you check Canvas, the announcement at the top, there's now less total points in the class. So it's a little bit easier to get an A. But I think it's worth it because these guest speakers have been very good. And anyway, so attend these if you like for the next couple of weeks. They're worth extra credit if you attend them. And I'm going to talk about 4 projects tonight, hopefully, so you've got some projects to do. And so let's talk about Windows overflows. And here we get a little bit into the dense technical details of the Windows defenses. So I'm going to go over it in a sort of cursory way. But it's good that you at least have some familiarity with these complicated things. Like Windows heap overflows, exploiting these vtables and such. I don't have that in the projects. That's kind of hard to set up. But that is what you have to do. So we'll talk about the protection measures for the stack, heap overflows, and then some other theoretical overflows, even some that are so theoretical that they haven't yet been observed in practice. So if you start with Linux code, back in good old GCC, you remember we had a project here with a simple buffer overflow where you've got a password that comes in with getS. So the password comes in with no length limit, and it can overflow the 10 characters set aside for it. And therefore, it can hit the control structures. So if you compile it in the normal way, it will have no stack protector, but you can turn on the stack protector with the -F stack protector, and then you'll use a different executable, which is a little bit bigger, like about 80 bytes bigger. So the protection makes the file a little bigger. It adds a little bit of assembly code to the file. And so if you disassemble it, you'll see here's the start of a function. This one here just has the normal prologue that pushes the old base pointer onto the stack, moves the old base pointer into the stack pointer to start a new stack frame, and then pushes something on the stack and then subtracts things from ESP. This whole mess sets up a new stack frame. And now, in addition to all that stuff, it copies some value from GS, a segment register 014, and puts that on the stack somewhere. So that is the stack cookie. And so then, if you look at the end of the function, this one here just does leave and return after moving something into EB or storing the saved EBX back into EBX. But this one here checks that value, GS0x14, it does an XOR of some value on the stack with that number that came from the GS, which is a segment register pointing to another area of memory. And if it doesn't equal 0, then it will go to stack check fail. So this is the implementation of the stack cookie. It puts a random value fetched from some other memory location at the end of this stack frame, and then when it's time to return, it checks to make sure that value has not been corrupted, and it doesn't bother trying to return unless that happens. So if you have a buffer overflow and you try to overflow the return pointer, this test will detect that, and you will not be able to take over the machine. So Windows has the same measure. And so you can do it with Visual Studio and it's in the projects. So you put exactly the same C code in Visual Studio, and then you make two versions of it and then compile it. This will compile it with stack cookies, and GS- will compile it without stack cookies. That's something just stands Microsoft abbreviation for it. And so then the PWDN without stack cookies is about 500 bytes smaller than the PWD with stack cookies. So you can disassemble them with IDA free, and you'll see the same thing. The one without a stack cookie just has the same kind of stack frame stuff, a push, a move, and a subtract to set aside a stack frame. This one has the same thing, but it then has to make the stack frame bigger, and then it fetches this security cookie and puts it on the stack. The same as in Linux. So that's the same story. So there are other stack protections. So the GS is the flag to tell Microsoft's compiler whether you want these security cookies on, which Linux calls canaries. And that's a 4-byte word printed on the stack. We saw it. The stack went from 14 bytes to 18 bytes when this was added to it. All right, let me quiet this. All right. So you'll have, say, a string variable here, a character array, which might overflow, and then you'll have the saved returned address and the saved EBP, and it puts the security cookie here. So if you overflow and hit the cookie, then it won't try to return, so you can't exploit overwriting either of those things. You can, in principle, still exploit the simpler overflow where you leak from one variable into another. The one we talked about before, not the most common kind of buffer overflow, but it is possible, and a security cookie does not prevent that. But that kind of overflow is usually far less harmful because it's not very common that the other thing you're rolling into is used to control the instruction pointer. So it tends to be non-exploitable, although in certain cases it might be. So to generate the cookie, it needs a random number. So it does this with a time, process ID, thread ID, another measure of time, just trying to get a random number. Are the stack canary values randomized each run? Yes. No, they are not static for given binary, as you see. They are based on the clock. This is a really important issue, and it is a huge problem. One that I saw the late Dan Kaminsky talk about at DEF CON. There are no real random numbers in your computer. This is actually a big problem. So you try to make a random number with all this, but of course it's not all that random. Now, if you're a normal human running the machine, then it's been up for a random amount of time before they click on something and launch the process. And so then these sort of times might be effectively random. But if you have something like a hardware device, like a firewall, that you just boot up and it just goes through a startup sequence and you manufacture 1 million of those firewalls, then it's probably not random this time. So that can lead to a problem. But in Windows, used by a human, these times are relatively random, one would think. But you can then wonder, and if an attacker can get malware on the machine to get the time values, then they might be able to predict things about the cookie, which is, of course, kind of an unrealistic test in that if you already have control of the machine, it doesn't really matter if you can overflow the stack cookie, but in a sort of abstract sense, this is a measure of how good your stack cookie is. And so under these conditions, if you find out how much you can predict it, it turns out you can predict some of the bits. So even though the cookie is 32 bits long, you can predict almost half of those bits. So in practice, a very powerful attacker who actually has the ability to run code on the box they're attacking would be able to lower the entropy of that cookie to 17 bits, and 17 bits is about 100,000. So then if they would have to run the exploit about 100,000 times to get lucky. All right, which is, if all 32 bits are random, that number would be 4 billion. So that stack cookie is not as strong as it could be, but it's still pretty strong. So anyway, we talked about that's the prologue modification and the epilogue modification doing this security check. All right, so it just checks, that's all it does. It compares it and then calls some kind of special handler to stop and warn you that something's gone wrong. And as I mentioned, you still have the problem that one variable could leak into another variable on the stack. And so to prevent that, now in the early days, Microsoft compiler would just put the variables on the stack in the order in which you defined them. But after this, it puts all the arrays at the bottom of the list so that it will look like this. Even if you defined it as name, password, and then a variable like isadmin, say a Boolean, in this case, I could overflow the password and I could change the value of isadmin, then I could become the administrator even without hitting the cookie. But now it takes all the variables that are not strings and puts them at the top, puts all the strings together at the bottom to try to make it so the only thing you can get by overflowing a string is to hit another string, because that one would imagine would be relatively harmless in most cases. So that's another defense. All right, and like I say, we talked about this. All right. Of course, if you use the parameters, then in contrived situations, there might be cases in which you can still control the EIP, but it's less likely. And now we hit the nasty stuff about the heap. In Linux, we did some heap overflows because the heap is just a simple structure and a linked list, and it wasn't really much harder than exploiting the stack. But in Windows, it's a lot more complicated. But the reason you'd use a heap, of course, is you have a lot of data that you only need to use temporarily that varies in size, like you're building a web server. It's going to have all these requests coming in. They might be very large, and you only want to hold a request long enough to process and answer it, and then you can throw it away and reuse that space for the next. So that's the kind of thing you use a heap for. Now, every process has a process heap. And that's like the default heap you can use for that process, and that's stored in a thing called the process environment block. And as we'll see, Microsoft software tends to just use the process heap because it's really old, but you can have other heaps. So that's just right here. You can get it with this fs : in the segment register at this location, download it from there. This is the way to get it. These two commands together will get you the default process heap, which is used by Windows API functions typically. But you can now create more heaps within the process heap if you want to, as many as you want with the heap create function. And so then you'd have the process environment block pointing to the default heap, then you'd have a list of heaps and all these dynamic heaps created inside there if you want to separate many heaps. So you use heap allocate to borrow a chunk of memory, and then when you're done you call heap free. Just like in Linux, you would call malloc and free. So a stack goes downwards, the heap goes upwards. It starts with 128 entry structures to keep track of free blocks. And so the fundamental issue is it's a linked list. It's really a doubly linked list. There are pointers to the next node and pointers to the previous node. And when you delete a node, you have to update these 4 pointers to hop over. And if I was able to overflow the data from this into that, I'd be able to change the metadata in the pointers. And so these write operations would start writing data and two addresses that are under my control. So if you have an overflow from one chunk on the heap to the next, then when you execute a free, you end up in control of a write operation. So that's useful. All right. But it turns out in Windows, it's a lot more complicated because Microsoft tries to avoid heap fragmentation. As you might imagine, if you keep creating nodes and deleting them, it's the same thing as filling up your hard disk with files of random size and deleting them. After a while, there's not a lot of contiguous available blocks in a row. So if you want to store a big file, you have to store it in many chunks instead of one, and that's inefficient. So it has a bunch of structures here to try to organize the heap and tidy it up. So if you want to exploit it, you can overwrite the pointer to the exception handler or the unhandled exception filter or a pointer in the process environment block. Those are various things you might want to overflow if you can overflow things on the heap. And so if you do that, then you could overflow a location which is used whenever a process exits. And that turned out to be handy because its location is fixed. So you might be able to overwrite that, and then you might want to restore the heap or at least run code that makes the heap appear to just be an empty heap so that you won't hit an error when it tries to use the heap. Anyway, Windows 2003 doesn't use these things, but there are other functions you can attack. And there is something called vectored exception handling, which stores information about handlers on the heap. And you can, in principle, overflow a pointer to these things to get control of the machine. And this is the kind of complex detail I don't plan to go into in any great detail. You should just be aware that this is the kind of consideration. It takes a bit of study to get this stuff going. But when you overflow, you corrupt the heap, so you have to repair it so that it won't cause an access violation. And the simplest thing is just make the heap look like a fresh empty heap. And there's an exception handler you might fix so you don't damage it. Anyway, now there's another object out there. We've talked about services and libraries, DIL files. There's another thing called COM objects, which are just another way to do approximately the same thing on Windows. And these are objects that are available, and they will be created when needed, just like a library would be loaded when needed. It's just a reusable code object. Remember, the whole point of Windows is to make money and to make it so you can reuse code and sell your code. So they have various types of containers you can put code in, and then you can reuse it under many different circumstances. And that's these COM objects are one part of that. So all COM objects have an interface that connects them to a program. And then they have a thing called a vtable. And the vtable is somehow used as pointers to get to these things. So if you could overflow these, you could get into the next object's vtable. They can have a kind of overflow within these vtables that control these COM objects. And it turns out that there are thousands of COM objects. They've just been piling up for decades in Windows. Remember, Microsoft has all this issue with backward compatibility, and a bunch of the vulnerable ones are never fixed. They're just put on a hate list. There's a thing called a kill bit list, which is COM objects that you shouldn't load anymore, but you can circumvent that. And this is an old simple defense. There was another thing back in the days of Microsoft ActiveX. There was a flag to say whether an ActiveX handle was safe to use or not, and you could just change that flag and convert an unsafe one into a safe one. You know, because this stuff dates from the really early days of Windows when their defenses were very primitive. So you can run this thing called OLE COM Object Viewer and see them, and I ran it on some box running Windows 7 or Vista, and there's just tons of COM objects on the machine. They have these long globally unique identifiers and do things like iPersist stream and insert table and so on. Just little library-like functions that you can use. All right. So anyway, there's other things you can overflow. For example, you can have a data section. Now, if I have a C program and a main function, I can create variables just up here, not inside any function. Those are global variables, and they'll go in the data section. And I can have the same issue. I can have a string here and then some data after it. And if I let you put more than 32 characters in this buffer, it will overflow and hit the next object in the data section. And the thread environment block and the process environment block could be overflowed. And that's another possibility, although I say that's a theoretical one that hasn't happened. Anyway, that's a quick overview of some more types of overflow that you can have happen in Windows. And let's take a look at some Cahoots. So we're at 127.8b. There we go. See, those are the ones that are too much work, and I don't have hands-on projects in this semester for them. I used to have some overflows of them, but they required really old versions of Windows, and I took them out. I had a Heap spray, but it only worked in, I think, Windows 2008 32-bit, which is out of support, so I took it out. All right, I guess that's enough, people. Okay, so what defense is also called a canary? Yep, a security cookie, the same thing. All right, what item is used by Windows API functions? Yep, the process heap is just the simple default heap, and that's what Windows API functions tend to use. All right, which item is added to a kill bit list? That's COM objects. All right, which API call is most likely to be exploitable by a heap overflow? When you free a chunk, just like in Linux, is when you have an operation that's simple to exploit. The others might possibly be exploitable, but it's not as easy. All right, which one of these is created when needed by another program? Those are the COM objects. These are all parts of the original program, but when you call a COM object, it then creates it, just like launching a service. All right. All right. All right.